doing an exercise in tangential gradient calculation. Okay, so the first one we've got here, so we've got these curves, all of them are, positive curves, not inverse, but curves going in a smiley face pattern, and this one's an inverse curve, and these two are circular topographies. So the first one, now the general formula for gradient is through this equation, y equals mx plus c. M is the gradient, that's what we'll be calculating. X is the x-axis, and c is where it cuts off the y intercept, and this obviously is the y-axis. Okay, so that's how things are. Generally, in a linear equation, for this, if something's like this, then the gradient would be negative. It'll be minus m. This would be the c, and it'll be y equals minus mx plus c. If it's equation that looks like this, then it'll be y equals x. And if it's an equation that is going like this, then the y-intercept would be negative and the gradient would be positive. It'll be y equals mx minus c, y equals mx minus c. Now these curves are a bit different because we'll have to take the point 2, 2, measure it here, which is this point, and then draw a line. This is what's different about tangents, because you have to draw a line and then pick the coordinates at either end of the line. Well, either end, or points that cover more than 75%, around about 75% of the line that you've drawn. So I'm going to draw all these lines now for all of the points, and then I'll get back to you, and then we'll start calculating the gradients for all of these coordinates on all of these curves. So 1, 2, 3, 4, 8, 12, 16, 20, 24, 28, 32. So we'll be doing 32 calculations. So bear with me, and I'm going to draw all the lines. Cheers. So I've labeled these coordinates, the lines are the coordinates, and yeah, that's how things are, and we'll begin to calculate the gradients from here. So I've just found out that at 2, 2, when I drew a line, a straight line at the tangential line, these are the coordinates I got. So x, y, x, y, and so the formula for calculation of gradient is delta y over delta x, which in actuality is y subscript 2 minus y subscript 1 over x subscript 2 minus x subscript 1. And you get, so this is x1, x2, y1, y2. So it'll be y2 1.5 minus, hang on, bear with me please. So in this case, the x2 and y2 is this, and x1 and y1 are these two. So it'll be y and y. So it'll be 6.5 minus 1.5 over 4.5 minus half, and that would be 5 over 5, it'll be 1. And it doesn't seem to be, this 2, 2 line doesn't seem to be interacting with a y-axis anytime soon, so we can't derive an equation out of it. What we can do is y equals, we now know that it's x plus c. We don't know what c is, so what we'll do is to take one of these values, one pair, and put it here. So we'll plug this in the value 6.5 equals 4.5 plus c, and we'll get 2. So it'll be c will be 2. So the equation will be x plus 2. Now we can double check it, and if we put y equals minus half plus 2, we get y equals 1.5, which is this. So yeah, check. Now the second curve, so at second at B, when I drew a tangent for -1 and 0.5, this line, the coordinates are -5 and 4 and -1/2 and 0, and the gradient calculation would be, so remember you have to write this formula every single time in the exam. So that will be here, 9. So the equation would be y equals 8, 9x plus c for now. I mean, it should be a minus, but so now we'll plug in a value for, yeah, we'll use this to find out. So it'll be 4 equals 8/9 times 5 plus c, and it'll be 40/9. And it'll be yeah, bear with me please. It'll be minus 0.44. So that's how we get the equation. Final equation would be 8/9 x minus 0.44. So for the part C, the coordinates we have to draw a tangent at would be 3 and 4.5. The coordinates would be first one I'd pick is 4 and 7.5, followed by 1 and 0, 0, and 0, well, no, hang on, 2 and 1. So there is an element of approximation. There is a subtle element of slight approximation. Okay, there's a subtle element of slight approximation, and that's because of visual limitations on the graph. The graph isn't full scale, it's a very small graph, so obviously I have to approximate. Now the gradient would be m modulus delta y over delta x y2, which is y subscript 2 minus y subscript 1 over x subscript 2 minus x subscript 1. And I will, this is so it'll be 7.5 minus 1 over 4.4 minus 2, 6.5 over 2, that's 3.25. The equation becomes 1 over 4 would be 1 over 4 would be 13 over 4x plus c. Now if I wanted to find out c, I'd go for and I'd plug in 2 and 1, so it'll be y equals 26 over 4 c. Okay, so that'll be 1 minus 26 over 4 equals c. So that'll be 26 divided by 4 is 6. 1 minus so y, yeah, we could do a common denominator. 4 minus 26 minus 22 over 4. So c would be minus 2 over 24, and the equation would be or we could just do okay, so we could just do that. Found out. Now this third curve we have to look at is fourth curve, sorry, is minus 3.5 and 6. So I'll pick out 2 points. The points I'm going to pick out are so these are the points I picked out, and I'm going to, these points were picked out from the tangential line. I drew this one, and then I picked these 2 points. And obviously there's a subtle element of slight approximation. So the gradient calculation would be now the gradient would be